Good evening, students. Hello. लास्ट लेक्चर में हम लोगों ने डिस्कस किया था। हेलो।
व्हाट गवर्नर्स के बारे में लास्ट लेक्चर में डिस्कस कर रहे थे। और रिलेशन हमने डिटरमाइन किया था व्हाट गवर्नर में। H इज इक्वल टू 895 अपॉन n स्क्वायर in meters, where h is the height of the governor and n is the speed of the governor. Okay. एक सिंपल कैलकुलेशन न्यूमेरिकल सॉल्व कर लेते हैं व्हाट गवर्नर पर। Calculate the vertical height of a watt governor problem. Calculate the height of the governor when it rotates at 60 rotation per minute. Also find the height when its speed increases to 61 rpm. Okay. Hello. 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 Okay. Okay. Calculate the height of the governor when it rotates at 60 rpm. Also find the height change in height when its speed increases to 61 rpm. As we know that height of the governor is equal to the 895 upon n square. Here speed n1 is given 60 rotation per minute and n2 is 61 rotation per minute. So from this equation, h1 is equal to 895 upon 60 rotation 60 square. Calculating this, we will get 0.248 meters. So height of the governor means vertical height of the governor from the plane of rotation of the balls masses. Okay, so if the governor rotates at rotate at 60 rotation per minute, then in that case the height of the governor will be 0.248 meters. Now height of the governor when its speed is 61 rotation per minute, so it will be equal to 0.24 meters. Now the change in height will be equal to the h1 minus h2. It means 0.248 minus 0.24. The change in height will be 0.08 mm, 008 mm, meters, sorry, not mm, meters, or 8 mm. Okay, clear? So numerical on watt governor are very simple because the watt governor is a very watt governor is the simplest type of governor. Now come to the next governor, centrifugal type governor, Porter governor. Porter governor. Now what is Porter governor? The Porter governor is a modification of a Watts governor, okay, with central load attached to the sleeve. As we know that there is no weight at the sleeve in the case of a Watt governor, but in a Porter governor, the sleeve mass will be neglected, but in a Porter governor, the mass of the sleeve will be considered. Okay, वॉट गवर्नर की जो सेंसिटिविटी होती है वो बहुत ज़्यादा होती है बिकॉज स्लीव पर कोई भी वेट नहीं है, मास नहीं होता. तो ड्यूरिंग एनी टाइम चेंजेस इन स्पीड, governor sleeve will moves very rapidly, and due to the inertia it will moving towards that particular direction. Okay, so eliminating this disadvantage of the watt governor, in Porter governor the mass of the sleeve will be considered. Okay, there is a load placed on the sleeve in a Porter governor. So here from the diagram the height of the governor will be h. Okay, let this is the point O, this is the point B, and suppose this is the point A. The tension in the upper arm is T. The force, centrifugal force is Fc, and the mass, weight due to the mass of balls will be small mg. Here, total mass of the sleeve is capital M, and the weight of the sleeve will be capital Mg. Okay, weight of the sleeve will be M into G. There is a friction force between the spindle and the sleeve and the spindle due to the relative motion. If the sleeve moves in downward direction, in that case the friction force will be acting in upward direction. If the sleeve will move in upward direction, then the friction force will act in downward direction. So the total net force acting at the center of the sleeve will be mg plus minus f by 2. Sorry, mg plus minus f, where capital M is the mass of the sleeve, g is the gravitational acceleration, and f is the frictional force acting between the sleeve and the spindle. Here, this sleeve supported at 2 points, so this total load will be distributed and distributed to these 2 points. Okay, so then in that case, total load acting at the point D will be mg plus minus f by 2. Is it clear? Okay. Let small m is the mass of each ball in kgs. Capital M is the mass of sleeve in kg. Now small r is the radius of rotation in meters. R is the small r is the radius of rotation of the radius of rotation. Small h is the height of governor in meters. Capital N is the speed of the governor, equilibrium speed of governor in rotation per minute. Omega is the angular velocity. Angular speed. Okay. Omega is the angular speed of governor. It will be equal to the omega is equal to the 2 pi n upon 60, and the unit is radian per second. Radian per second. Fc is equal to the centrifugal force acting on the ball. Fc is equal to the m into r into omega square in newtons. T1 is equal to the force in the upper arms in newtons. T2 is equal to the force in the links in newtons. Alpha is equal to the angle of inclination of the arm inclination of arms. Okay, to vertical. Beta is equal to the angle of inclination of links to vertical. ओके, यहाँ पर हमें डिटरमाइन करना है, रिलेशन डिटरमाइन फाइंड आउट करना है हाइट ऑफ द गवर्नर एंड स्पीड ऑफ द गवर्नर के बीच में. ओके, तो यहाँ दो मेथड्स हैं इसे डिटरमाइन करने के, रिलेशन फाइंड आउट करने के लिए. एक है इंस्टेंटेनियस सेंटर मेथड, दूसरा है मेथड ऑफ रेजोल्यूशन ऑफ फोर्सेस. तो हम इंस्टेंटेनियस सेंटर मेथड से सॉल्व करेंगे. यहाँ पर हम आर्म्स को आगे की तरफ बढ़ा देंगे और इस पॉइंट डी से एक हॉरिजॉन्टल लाइन ड्रॉ करेंगे. ओके, लाइक दिस. सपोज ये दोनों इंटरसेक्ट करते हैं पॉइंट सी पर. नो, दिस आई पॉइंट है. ठीक है, दिस इज द पॉइंट आई. जो सेंट्रीफ्यूगल फोर्स है वो आपका आउटवर्ड डायरेक्शन में लगेगा यहाँ पर, और जो रेडियस ऑफ रोटेशन है बॉल का, पॉइंट ए, ये बी ए बी के बीच की लेंथ हमारी यहाँ पर, आर्म्स का वर्टिकल से जो एंगल है, वर्टिकल एंगल है वो अल्फा है, और जो लिंक्स हैं आपके वो वर्टिकल से एंगल बना रहे हैं बीटा. दिस इज द रेडियस ऑफ रोटेशन. हाइट ऑफ द गवर्नर है हमारे पास स्मॉल एच. टेंशन इन द आर्म इज T1 and in the arm, lower arms links is T2. पॉइंट बी से एक वर्टिकल लाइन ड्रॉ कर देते हैं. इस वर्टिकल लाइन के अलोंग फ्लाई बॉल्स का वेट अप्लाई होगा mg, और पॉइंट डी से स्लीव पर लगने वाले टोटल फोर्सेस अप्लाई होंगे, जो कि मैंने आपको अभी बताया था, mg प्लस माइनस f/2 है. इज इट क्लियर? ओके. आई सेंटर मेथड में, आई के पॉइंट आई के अबाउट, इंस्टेंटेनियस सेंटर मेथड है ये. इंस्टेंटेनियस सेंटर मेथड में पॉइंट आई के अबाउट अगर हम फाइंड आउट करें मूवमेंट, ओके, तो इस पॉइंट आई के अबाउट जो मूवमेंट आएगा सारे फोर्सेस का, वो जीरो होना चाहिए. ओके, इंस्टेंटेनियस सेंटर मेथड में पॉइंट आई के अबाउट सारे फोर्सेस का जो मूवमेंट होगा वो जीरो आना चाहिए. क्लियर? ओके. Now taking moment about the point I, instant instantaneous center method. Okay, taking movement about point I. Okay, so from here देखिए, moment of centrifugal force about the point I will be equal to the, suppose this is the point C. Okay, so moment of force Fc about the point I will be force into perpendicular distance. Here the perpendicular distance between centrifugal force Fc and I is Bc. Clear? This force produces a counterclockwise movement about the point I, and the remaining two forces will produce a clockwise movement about the same point I. So movement of force weight of ball mg will be equal to mg into distance, which distance is IC, plus weight of the mg plus minus f, force applied at the point D multiplied by distance is ID. Okay, okay. Okay. Now divided the equation with BC. FC will be is equal to small mg into IC upon BC plus mg plus minus f upon 2 into ID upon BC. Clear? Now this is the equation number 1. From right angle triangle BCI and right angle triangle BCD. Here this angle will be equal to the alpha and this angle will be equal to the beta. Okay. So from here IC from right angle triangle BCI, IC upon BC will be equal to the tan alpha and from right angle triangle BCD, tan beta is equal to the CD upon BC. Okay. Okay. Now from the equation number 1, FC is equal to the small mg into IC upon BC is tan alpha plus mg plus minus f by 2 ID will be IC plus CD upon BC. IC upon BC is equal to the tan alpha and CD upon BC is equal to tan beta. So from here FC will be equal to the mg tan alpha plus mg plus minus f by 2 IC upon BC is tan alpha, CD upon BC is tan beta. Okay. Now FC equal to mg tan alpha कॉमन कर लेते हैं इक्वेशन से, यहाँ ब्रैकेट में जाएगा 1 प्लस mg प्लस माइनस f अपॉन 2 mg 1 प्लस tan beta upon tan alpha. Okay. We know that FC is equal to the mr omega square equal to mg tan alpha bracket 1 plus mg plus minus f upon 2 mg within bracket 1 plus k. where k is equal to the tan beta upon tan alpha. Here m is cancelled from m. Omega is equal to 2 pi n by 60. Okay. And from the right angle triangle OAB, from this right angle triangle, tan alpha will be is equal to small r upon h. Okay. Tan alpha will be is equal to small r upon h. So from here r omega square is 2 pi n by 60 whole square will be is equal to the g. Tan alpha is small r upon h within bracket 1 plus mg plus minus f by 2 mg 1 plus k. Small r is cancelled by the small r. H will be is equal to the 3600 into g upon 4 pi square 1 upon n square 1 plus mg plus minus f upon 2 mg 1 plus k. Calculating this value, we will get 895 upon n square within bracket 1 plus mg plus minus f by 2 mg 1 plus k. Okay. If alpha is equal to the beta, in that case k will be is equal to the 1 because tan alpha is equal to tan beta and friction force is 0. In that case h will be is equal to the 895 upon n square 1 plus mg upon 2 mg into 2 m is, so from here h will be is equal to the 895 upon n square m plus capital M upon small m. Okay. So this is the general equation. हेलो, एक न्यूमेरिकल इस पर हम लोग सॉल्व कर लेते हैं, एक सिंपल न्यूमेरिकल. ठीक है. The arms of a Potter governor. The arms of Potter governor are 300 mm long. The upper arms are pivoted on the axis rotation. The upper arms the upper arms are pivoted on the axis of rotation. The lower arms are attached to a sleeve at a distance 40 mm. Okay, from the axis of rotation. From the axis of rotation, the mass of the load on the sleeve, capital M, is 70 kg and the mass of each ball is 10 kg. Determine the equilibrium speed when the radius of rotation of the ball is 200 mm. Full stop. If the friction is equivalent to a load of 20 Newton at the sleeve, what will be the range of speed for this position? What will be the range of speed of the rotation? Okay. According to the question, सबसे पहले हम लोग क्या करेंगे, एक डायग्राम बना लेंगे सिंपल फॉर द गवर्नर. The length of the upper arms and the lower arms are equal. O, this is the point O, point A, point B. This is the point C, point D. Okay. Here, suppose this is the point E. The height of the governor is H. The length of the upper arm is 300 mm. Length of the lower arm is 300 mm. The distance from the axis of rotation is 40 mm. Okay. And radius of rotation is R. R is given 200 mm. Okay. तो इस कंडीशन में अगर हम फाइंड आउट करें, ये एंगल है अल्फा, लेट दिस एंगल इज बीटा. नाउ फॉर दिस केस, let capital N is the equilibrium speed. in rotation per minutes. Now from the upper triangle OAB, height of the governor will be equal to the under root OA square minus AB square. Is it clear? Here the distance of OA is 300 mm and AB is 200 mm. Now calculating this, H will be equal to the 224 mm. Height of the governor will be 224 mm, or say H will be 0.224 meters. Clear? Now from this right angle triangle OAB, tan alpha will be equal to the R upon H. H is 224 mm. Now calculating this, tan alpha will be equal to the 0.893. Okay. Now from the right angle triangle AEC, tan beta will be equal to AE upon, from here tan beta will be equal to AE upon EC. Okay, and AE is equal to the AB minus BE. Here AB is 200, BE is 40. So from here AE is equal to 160. So EC is DF can be calculated, EC is can be calculated. EC will be equal to the under root AC square minus AE square. Okay. Now tan beta will be, not tan beta, AE will be equal to the 160 mm and EC will be equal to the under root AC square minus AE square. Here AC will be 300, AE is 160. So from here EC will be 254 mm. Now from here tan beta will be equal to the AE upon EC. A is 160, EC is 254. The ratio of these values is 0.705. Now the value of K will be tan beta upon tan alpha. Tan beta upon tan alpha. Here tan beta is 0.705 upon tan alpha is 0.893. So value of K will be 0.705. Wait a second. This will be equal to the 0.63. Okay. Now we know that n square will be equal to the 895 upon h within bracket small m plus capital M by 2 1 plus k upon small m. Now solving this, 895, h is 0.224 meters, small m is 10, capital M 70 by 2, 1 plus 0.705 divided by 10. So from here equilibrium speed will be 167 rotation per minute. Okay. Okay. Range of speed when friction of equivalent to load 20 Newton. Let N1 is equal to the minimum equilibrium speed and N2 is the maximum equilibrium speed. Maximum equilibrium speed. Now we know that when the sleeve moves downwards, okay, if that sleeve will move downwards, in that case the frictional force acts in upward direction, and because the frictional force always acting in opposite direction of the motion, and if the sleeve and the minimum equilibrium speed is given by, in that case minimum equilibrium speed will be given by n1 square is equal to the 895 upon h 1 plus capital Mg plus minus f upon 2 mg 1 plus k. Okay. So from here n1 square is equal to the 895 upon h is 0.224, 1 plus capital M is 70, G is 9.8, minus F is 20, divided by 2 into 10 into 9.8, 1 plus 0.705. N1 is equal to the, from here N1 is equal to the 164.8 rotation per minute. Okay. Similarly, when the sleeve moves upwards, in that case frictional force will be acting in downward direction. In that case the frictional force has the frictional force acting in the direction of the weight applying. So N2 square will be equal to the 895 upon h 1 plus capital Mg plus friction force divided by 2 into small mg 1 plus k. Okay. So from here N2 square will be equal to the 895 upon 0.224 1 plus 70 into 9.8 plus 20 divided by 2 into 10 9.8 1 plus 0.705. Now calculating this, N2 will be equal to the 169 rotation per minute. Now the range of speed will be equal to the range of speed will be equal to the maximum minimum minus minimum speed. The maximum speed is 169 and minimum speed is 164.8 newtons. In that case the range of speed for the governor having a frictional force of 20 Newton will be equal to the 4.2 rotation per minute. Okay. Okay. Thank you so much.